ABC company, they make bungee cords. When the manufacturing process is running well, they have a normally distributed length of bungee cord. Mean is 45.2 centimeters, standard deviation is 1.3. And what the criteria say is that any bungee cord shorter than 42 or longer than 48 get rejected. And the first thing I want to know is, if 20,000 bungee cords get made each day, how many would they reject on an average day? So what we need to find is how many bungee cords, or what percentage of bungee cords are shorter than 42 centimeters, and what percentage are longer than 48. So we've got two things to do here. Got to deal with our 42 centimeter threshold and find its z-score. X being 42 centimeters, mean is 45.2, standard deviation 1.3. Divide that out, we get a z-score of negative 2.46. So any bungee cord that has a z-score of less than negative 2.46 would get rejected. Before we get into what that means, let's take a look at 45.2 centimeters. Sorry, 48 centimeters. Substitute in 48 for x, the rest will stay the same. And we get a z-score of 2.15. So any bungee cord that has a z-score of more than 2.15 will also get rejected. So let's tie this back into the normal distribution. We said that these bungee cords get normally distributed. The mean would have a z-score of 0. And I only care about anything that has a z-score of less than negative 2.46 or greater than 2.15. So to find which percentages fit in those regions, we go back to the z-score table. A z-score of negative 2.46 would be right there. So 0.0069 or 0.69%. At this point, changing it into a percent is less useful because the question is asking how many bungee cords would get rejected. So we would have to turn that back into a decimal anyways. Our other z-score cut point would be 2.15. And we get 0.9842. However, this does not mean that 98.42% of all the bungee cords would get rejected. It means that there's 98.42% to the left of 2.15. And if we look at our normal distribution, we want what's to the right of 2.15. So really, this would be 1 minus 0.9842, which would be 0.0158. So we're going to reject both of those. We can combine them together. Means 0.0227 or 2.27% of the bungee cords get rejected. So on a typical day of 20,000 bungee cords, how many of them would actually get rejected? We need to multiply 20,000 by 0.027. And once we do that, we would see we'd have 540 cords get rejected. Question B is asking what action the company might take because of these findings. They might think that 540 bungee cords a day is enough, that they don't need to change their thresholds. They might think it's too much and decide to take measures to reduce the number of cords that get rejected. Now, the easy thing to do with the long cords is to just shave a little bit off, and then they would fit the criteria that they need. The short cords, it's a little more difficult to add a little bit to. So they might change their threshold of what they decide to reject. They might make some alterations on their machinery so that most of their cords get within those threshold ranges, or they could do any number of other things. B is mostly an opinion type question that you'd be able to answer just by stating your opinion.